There are moments when the universe doesn't speak, it whispers. In July of 2025, one of those whispers crossed the deep beyond and reached us. Telescopes around the world detected a faint, distant object. It was designated 3I/Atlas. At first glance, it resembled an ordinary comet. But as astronomers zoomed in, the unease began. There was no classic tail, no clean ice plume pointing away from the sun. Instead, a dense, asymmetrical veil of dust wrapped around its core. Soft, unstable, almost like a suspended teardrop in space. And then came the undeniable revelation. This object wasn't bound to our sun. Its hyperbolic trajectory confirmed a truth we almost never witness. This was not from here, only the third interstellar visitor in all of recorded human history, and yet, perhaps the most mysterious one of all. It didn't come offering answers. It arrived demanding new questions. To understand 3I/Atlas, we have to look back at the brief history of those who came before it. The first was Oumuamua, detected in 2017, a long, cigar-shaped traveler with no comet tail, no visible ice, and a strange way of reflecting sunlight. It spun slowly, then vanished into the dark, leaving behind speculation and controversy, even whispers of artificial origin. 2 years later came 2I/Borisov in 2019, far more familiar. A traditional comet, except for one impossible detail. It wasn't born anywhere in our solar system. And then, in 2025, came 3I/Atlas, discovered by the Atlas Survey in Chile. And once again, the rulebook didn't just bend, it broke. Its orbit screamed outsider. 130,000 miles per hour, diving inward on a steep, almost backwards path. It will never return. As UCLA astronomer David Jewett put it, it's like catching sight of a rifle bullet for 1,000th of a second. You can't trace it back to where it came from. But there was one clue we could read: its age. Calculations suggest it came from the thick disk of the Milky Way, a region of ancient stars, older than our own sun. From the very first observations, 3I/Atlas refused to behave like a normal comet. It began activating far too early, already emitting gas and dust while still beyond the orbit of Jupiter. At that distance, sunlight is weak. Comets should still be asleep, frozen, silent. But Atlas was already awake. That meant something important. Its chemistry was different. It carried materials that sublimated in extreme cold, far more volatile than the water-rich comets we're used to. Early estimates suggested its nucleus could measure up to 6 kilometers across, making it potentially the largest interstellar object ever detected. Yet unlike Oumuamua, long and tumbling erratically, Atlas appeared almost spherical, calm, balanced, a near-perfect relic, frozen in time. It wasn't chaotic, it was ancient, preserved, waiting. A fragment of a system long gone, or perhaps a planet that never formed. A messenger from a place no human eyes have ever seen. 2 weeks earlier, on July 21st, 2025, the Hubble Space Telescope had already captured the appearance of the comet. The image, sharp and poetic, revealed a body wrapped in an asymmetric cloud of dust, as if a strong wind were blowing from only one side. Instead of a tail stretching away from the sun, the brightest glow was facing toward the sun, a visual paradox. The explanation lies in its angle and speed. 3 Atlas is diving into the solar system on a steep inclination, and the light we see is the reflection of particles released from its sunlit face, bending under radiation pressure, like a beam of headlights cutting through the night. Brightness models indicate that its nucleus measures less than 6 kilometers across, perhaps barely 1 kilometer, if most of the light is coming only from dust. Small, dark, and coated with complex organic compounds that reflect just 5% of sunlight. 3 Atlas is, quite literally, a shadow traveling among the stars. October of 2025 will mark a historic moment. The comet will pass about 30 million kilometers from Mars, far too distant to pose any danger, but close enough to offer an unprecedented opportunity. The European Space Agency, ESA, is preparing a coordinated observation using the Mars Express and the ExoMars Trace Gas Orbiter. Their stereoscopic cameras and spectrometers will attempt to capture the color, structure, and gas composition of the comet. If the brightness allows, we may be able to identify the shape of its nucleus and even detect specific molecules such as water, CO2, and carbon monoxide. NASA is also considering using the MAVEN spacecraft and the Mars Reconnaissance Orbiter, while China evaluates deploying Tianwen-1. It will be the first time in human history that multiple nations observe, from another planet, an object arriving from outside the solar system. Farther out, the JUICE probe on its way to Jupiter, and even Lucy, en route to the Trojan asteroids, may also attempt to capture its passage. Every single observation will serve as a rehearsal for the future, a way to learn how to respond quickly when the next visitor arrives. But not everything is consensus. Ever since the mystery of Oumuamua, part of the scientific community has considered the possibility that one of these objects might have an artificial origin. Harvard astrophysicist Avi Loeb reignited the debate after noticing the peculiar brightness of 3 Atlas. To him, certain characteristics resemble a reflective, perhaps even metallic, surface. Others, however, argue that all the data so far can be explained naturally. The orientation of the dust, the forward-facing glow, the extreme chemistry. There are no orbital deviations that suggest propulsion of any kind. Still, the idea of an interstellar artifact invites bold thinking. Loeb even proposed using NASA's Juno spacecraft to intercept the object as it exits the solar system, using Jupiter's gravity as a slingshot. It would be a risky, yet potentially revolutionary, maneuver. Even if such an intercept never happens, the discussion reveals something deeper: humanity's relentless drive to understand, and perhaps one day, to find other builders among the stars. In just 8 years, we went from a universe centered around the sun to a cosmos filled with visitors arriving from other stars. Each one carries fragments of systems that may no longer exist, shards of lost worlds. By studying them, we open windows into eras and places forever beyond our reach. Future missions, like the Comet Interceptor from ESA and JAXA, are already being prepared. A spacecraft will wait at Earth's L2 point, and when a new object is detected, it will launch to meet it head-on. Cameras, probes, and spectrometers ready for a front-row encounter with cosmic history. These interstellar messengers may teach us how planets form, how organic molecules spread, and perhaps even whether life is a common phenomenon in the universe. 3 Atlas, with its ancient icy glow and reddish dust, is only a prelude. As it fades into the darkness, one question echoes in the human soul. When will the next one arrive? And when it does, will we be ready to recognize it? To hear, once again, the whisper of the stars?